Today we're going to do some instrumentation questions. So let's get started. Um, a crater on the surface of the moon has named Saturn has a diameter of 109 kilometer. Yes. Is it possible for yet living animals to? Yeah, this is an easy question. So we have this theta as 1.22 lambda divided by d. So 1.22. Let us take this visible wavelength as 5.50 times 550 times 10 to the power minus 9, which is 550 nanometer, divided by 15 times 10 to the power minus 3, which will give us 4.47 times 10 to the power minus 5 radians. So what we have is what we will have is angular size of the crater. Um, wait, angular size of the crater as angular size of the crater as diameter of crater divided by distance. So this will give us 109 times 10 to the power 3 because it's a distance to the moon is 384,400 times 10 to the power 3. Therefore, it will give 2.83 times 10 to the power minus 4 radians. So, just compare this with this. We have theta crater as this right here, the but yet it can resolve even a smaller one. So yes, it can resolve it, right? Another question: what would be the diameter of a radio telescope working at wavelength lambda equals 2 centimeter with same resolution as optical telescope with diameter that? So let us do that question right here. We have theta radio to theta optical. So 1.22 lambda divided by d was 1.22 lambda divided by d, or lambda radio by diameter of radio equals lambda optical divided by diameter of optical, right? So we will have, we know as 1 radian equals 180 degree by pi multiplied by pi, which is 180. Pi is 180 and 1 radian equals 180 by pi. So 7 centimeter by d radio divided is equals to 550 times 10 to the power minus 9 divided by 0.15. Let's calculate. The radio comes as, I guess, 6123 divided by 11. 5454 times 54 meter. Easy question. So another question we have as new observation. If I got minimum diameter of the telescope to resolve, we know that the position black hole is the reason of bad high 8.3 kiloparsecs. We have this, we have this. It's an easy questions. So what we have is mass. We would have this kind of a long question actually, and yeah. So we would have radius of black hole given by 2 cm divided by c square, right? So 2 times 6.67 times 10 to the power minus 11, and mass is 100 times the mass of sun. So this is the mass of sun divided by, you know, 3 times 10 to the power 8 there. Or use what is given there, okay? So it is 2.99 something something. So we get this as 296,855.035 meter. We have diameter equals 2 times the radius. We have angular size equals to diameter divided by distance. So 2.96855.035 multiplied by 2 divided by distance is 8.3 kilo parsec. So kilo is this, and 3.26 times 9.46 times 10 to the power 15, because it is 3.26 times the light year. Therefore, angular size comes as angular size comes as 2.3194 times 10 to the power minus 15 radians, right? So, okay, what just happened? Let's mm, let me add template. Um, let me after. Okay, so then what we get? What did we get there? We get, oh, we get 2.3194. Okay, so we have for telescope theta equals 1.22 lambda divided by d, right? So 2.3194 times 10 to the power minus 15 equals 1.22 550 times 10 to the power minus 9 divided by d. Therefore, we get the diameter of telescope as yeah 9298956.6 meter. It's the minimum diameter of the telescope. Um, Kind of an easy question. So the last telescope, oh, fits perfectly in the frame zone. F2. Okay. Okay. Then wait for seconds. You could read this. Okay, this is then kind of a great question, but mm, yeah. So we could do it. We could actually do it. So FOV FOV is FOV of eyepiece divided by magnification, right? So we have angular size as, I suppose, 1731 times 2 divided by 3842. This is the, the diameter. So 400 is the distance to the moon. So 9.03 times 10 to the power minus 3. So it is 0.517 degree for the telescope, right? So we'll get V equals d by t. So d equals vt. So how much time did it take? It took 45 seconds to go from there to there. So 9.8 with this much of velocity. So it will be 444.6 meter by car. So if we do have d equals 1 kilometer, so angular size will be 444.6 divided by 1000, which is 0.4446 radians. So it is, and 5 point, let's consider it a beta. So in the question number 3, we have find the, I can find out theta. Okay, in the, okay, no, okay. So we have this FOV of objective as 10, diameter as 10 centimeter, because we just got the accurate details 40 centimeter, and we have f by 2. So focal length will be f to x by 10, therefore x is 20 centimeter. So magnification is of course to 20 divided by 40, it is 0.5. So 2 FOV will be theta equals FOV of objective lens divided by magnification. I suppose, I mean FOV of eyepiece divided by FOV of eyepiece divided by magnification. So FOV of eyepiece will come as 0.5 degree. So we will have at something like with the cable car, it was an overestimation, but with the moon swan, it was accurate. The the way the moon swan was accurate, right? It was rather really wrong because of a lot of reasons. Because we have to consider a lot of effects into there. So another one. hmm Okay. So now we have any other questions? Um, thin conversing. Yes, yes. Okay, focal length is 10 centimeter from the infinity. This change is infinity. Okay, let's do some questions. I will end it up here for today. So, so we would have focal length is 10 centimeter. Star is at infinity. Image distance we consider it v. So 1 by f because it's an easy question. This is the object distance. So 1 by f would be 1 by v because u is 1 by infinity equals 0. So f equals v. So image distance image distance will be 10 centimeter, and magnification equals image distance by object distance. 1 by f equals 1 by v dash plus 1 by u dash. So 1 by 10 will be 1 by v dash plus 1 by 30 minus 10, right? Because the okay, so I suppose we get this as 1 by 10 minus 1 by 20 equals, therefore v dash equals 20, right? This image become a 20. So we have this question for, so for first it was uh we we must do image by object for magnification. So 20 divided by 20 for the second lens we'll get as 1. So let's go to question number 3. 1 lakh kilometer, I guess. 1 million kilometer. Recalculate the distance from the first lens. Let us do 1 by f equals 1 by u plus 1 by v, and we have this, and 1 million whatever is in 1 by v. So we have v as 10, therefore we get the resolution as 1.22 at 600 nanometer wavelength and 0.05 meter of this diameter. Then we get 1.46 times 10 to the power minus 5 radians, right? So we know 0.01 arc seconds will be 1 by 360.123 degrees, and we could calculate the the counterparts. So in radians, the two stars are separated by 4.84 times 10 to the power minus 8 radians. Easy one. So if we talk about a lot of telescope like focal length, focal length telling 4.7 focal length. Okay, we have a lot of questions here, I guess. Mm, and converting if 10 centimeter. Okay, this is the question today. I don't know. Yeah. So this is the question of today. I hope you understood it all. So that's it. We'll return later on with more questions. Thank you.